In tutorial block 5, you will learn how to design a basic circuit project, and we will start with the Josephson transmission line. Now, I've opened NioPulse, and we can start our project by selecting Circuit Project. Under Circuit Project, let's give it a name. I'll give it block 5 A JTL. When you select the vendor, this will tell other users who built this circuit. Let's call it Tutorial Master. You can select from a range of spice engines. We will stick to JSON for the moment. And we can select Finish. On our tutorial, on our circuit schematic view, we can see schematic editor, a list of components available to JSON, and our project outline. If you do not see the project outline, you may find it at Window, Show Views, Other, or Project Outline as displayed here. Now, to start the JTL, we need Josephson junctions. We can select the Josephson junction from the component list. The available Josephson junctions are only one. This is the latest version, and it was created by NioCAD. I can click on it, left click and drag to my screen and place my Josephson junction model. On the second model, some inductors. A few inductors are available. If I select the non-storing inductor, the circuit schematic symbol will represent an inductor with only 2 loops, which in RSFQ would indicate that it is non-storing. If I place an inductor on the canvas, I can use Ctrl R to rotate it. Click and drag to a node to make a connection. Place, Ctrl R, click, and it will connect where I want it. And I can place my fourth and final inductor and connect it to my Josephson junction. Now this forms JTL almost. What I still need is a resistor. Drag this to my canvas, and another resistor, and ground. For the moment, let us connect ground to each of the Josephson junctions. Now I can connect the ground to a resistor by also dragging it there, or I can use the handy wiring tool. My final component would be a resistor, added from the top. Let's just connect it in and move it out, and tie up my circuit. In my basic circuit, I do not need to add parasitics, as NioPulse will attempt to calculate these later. When I am happy with my circuit, I can save it, but I still need to assign values. The inductors, 2 picohenries will do. Damping resistors of 1 ohm will do for my specific example, and I will need a bias resistance of almost 7.5 ohms added through the dialog box by clicking on the component or by clicking on the property. The final thing to do to make this a JTL would be to assign a model to the Josephson junctions. Josephson junctions need models, and I can find under the model tab that none are assigned. So let us create a new model, and to start with, let us select Josephson junction. The others may not persist in your version of NioPulse. As a name, I will call it JJ250. By default, only 4 parameters are selected. R-type 0, which would mean that it has almost infinite, it has an infinite normal resistance, in which case Rn doesn't really matter. Capacitance and critical current. So for a 250 microamp junction, let us select or set a value of 250 microamp as critical current, and give it a capacitance of 1.25 picofarad, which is pretty standard for a 1 kiloamp junction process. And keep R type 0. Area parameter I'll keep to 1. Area scales the junction's critical current, normal resistance, and capacitance. When I select the second Josephson junction, I can assign the same model, and I will have a circuit with 250 microamp Josephson junctions. I may save, and now my circuit is complete.